This is a great little shaker table, and while I was building it, I took a lot of video footage and I put that together into a build video, and that's what you'll see today. I hope you enjoy it. Here's a SketchUp drawing of the Bump-Sluice shaker table that you can refer to if you want to build this. It's got a couple of minor improvements. I would do it. Anyway, I've moved the water bar from here to here. That allows me to spray the water back against this back shelf, and that makes the water flow more laminar for the shaker. I also moved the exit port of the tailings tray. That's important because it allows easier plumbing into the water supply. Otherwise, this is exactly how I built it. You can see the flexure joints, the motor in here, the coil of copper wire, the two magnets, the bump mechanism here. So to start the project, I cut 4 flexures. This is 60 thou thick garolite. Garolite is epoxy fiberglass, and it's extremely resilient material, so I think that's going to last forever for the flexure. The flexures are mounted to a couple of pieces of plywood that I cut out. This is a 3/4 inch and 1 inch wide. I've got these rails positioned. This is a square, so that keeps that square. And I've got a couple of spacers in here, and I use those spacers to keep the part exactly lined up while I put the holes in. All right, so the first one went together perfectly. There's just enough slop in the holes to be able to get it perfectly lined up. My spacers are in there, and they're tight. So I'm just going to tighten everything down just the way it is. I'm going to use a piece of plywood as the top of the table, and I'm going to cut the grooves in here. All right, there it is, all clamped up. Lots of clamps on it. So I did this one in the back first, and then I've got the other 3 clamped down. And now I'm gluing up the, these are the flexure supports. I actually had to change from plywood to this white oak because the plywood just totally sucked. And I want the strength to prevent bowing of the this 1/2 inch plywood. I want the strength of the white oak. Now, it's crucially important that these two are parallel with each other. If they're not, and you try to flex the flexure, you'll get binding forces, which will greatly stiffen the flexure, and we don't want that. So I've got 2 spacers in here right now, and I'm going to have to remove because I don't want to glue them in. But those spacers are exactly the same length, so that guarantees that this is parallel with that. I'm going to trim these edges up a little bit on the table saw. You could also take a plane and plane that off flat. And let's see how we did in terms of planarity. Almost perfect. So there's very little belly in that at all. So that's certainly good enough for the top of the table. I'm going to cut the grooves in this using a table saw. I've got to do that really carefully because I'm going to do it, of course, upside down where I can't see what I'm doing. So I've got to mark exactly where I want the grooves to go. All right, so here I have the SketchUp drawing in front of me. It shows the grooves location, and I'm just going to transfer that information onto the platform surface. All right, so you can see the pattern. The long grooves are the main transportation grooves that run the heavy stuff that way. And the shorter grooves bring material, the heavy material, from over here over to here where it gets dumped and then transported. How did I come up with a pattern? Well, I've made 5 or 6 different tables and lots of experiments with different cuttings of the neoprene mats and so forth, and I found that this idea will work very well. I'm quite confident. So the way I'm going to cut it is using a table saw and an 1/8 inch thick blade, 2 passes, because I want the grooves to be 1/4 of an inch wide. And what happens is I'll get a nice launch at the end of the groove because of the curvature in the blade. I made some test cuts, and you can see them here. I actually have tried to protect the surface with a layer of epoxy, which is going to work fine. Anyway, maybe you can see the launch. These grooves are about 2 millimeters deep, which is perfect. And there's the launch, and the curvature in the blade gives me a natural launch. And I figured out that I need to put the center of this blade 1.5 inches back from the end of the groove that I want. This mark is for the end of that groove, moved back 1.5 inches, and etc., all the way out to the last groove. I will transfer that mark onto here. That's what I'll use when I'm cutting the grooves to stop the cut. So the first cut needs to be 1 inch away from here, and then it's 3/4 of an inch all the rest of the way. All right, so I've got it all marked out here. Groove number 1 is 10 inches away from the fence and so forth. So I just made a test cut, and I'm going to measure the depth of that. And the depth is about 86 thou, which I consider to be perfect. That's just a little over 2 millimeters. So there's the blade protruding about 85 thousandths of an inch above the surface of the table. I'm going to run this along the fence. So if I were cutting groove number 1, I would have the fence over 10 inches, and I would cut to here. And I'd do that twice, but I'd move the fence 1/8 of an inch because I want a 1/4 inch wide groove, and this is only 1/8 of an inch wide blade. So I'd move the fence over 1/8 of an inch and make another cut. And all I have to do is to keep straight where the fence is for each one of these cuts, because if I screw it up, I basically ruin the piece. So I'm going to do it very slowly and carefully, thinking about what I'm doing. Well, that took less than 10 minutes. It's super fast compared with cutting those grooves in the mat, the neoprene mat, which is a big job. Okay, so now I want to, of course I want to smooth the bottom of the groove a little bit, but I'm most concerned with the launch region because the gold's got to walk out of the groove and back onto the table. So the launch is quite important. And so I'm going to take my time with the ends of these grooves. I'll start with 80 grit sandpaper, and then I'll work up to 120 and probably 220. Then I'll put a layer of epoxy on the whole thing that'll soak into the groove and make it watertight. So let's start with the end of this bottom groove, 80 grit sandpaper. I double it once and twice, and that makes a shape that's like that. And now the gold wants to come out the bottom, the lower part of the groove, so I just work that part of it. Okay, after 80 grit, this is what things look like. I can feel the transition is pretty smooth, but it's still not as smooth as I need it to be. These transitions are quite important to the operation of the table, so I gotta work on this and get it right. I mean, the table will work, but what'll happen is the gold will, especially the fine gold, will just sit down here and won't be able to get out of here. And I don't want that. I mean, it's livable, but I don't want it to do that. So I'm going to continue, I'm going to switch to 120 and try my best to get that smooth. All right, I'm going to continue with 150. Exactly the same plan. Smooth the grooves and smooth the table. Okay, the table is down to 220 everywhere. The grooves are quite smooth. Now I'm going to put the first coat of epoxy on everything, and I use this product from Aero Marine in San Diego. It's 321 is what they call it, and it's really good stuff. I'm sure there's other products that are just as good, but I like it. It's a very thin, non-viscous or low viscosity epoxy that'll soak into the wood. All right, here's 20 minutes later. The epoxy has soaked into the table, and I noticed that it's almost all gone. There's still some in the grooves, and it really hasn't even started to set yet. So I'm just going to smooth it out a little bit and leave it for a while more. So it's been about 30 minutes since I mixed the epoxy, a little bit more, and it's starting to get thick. Not really thick, but just starting to set. So I want to get it off of the table now because I don't want to leave it on there and have the nightmare of trying to sand it all flat again. All right, here I'm gluing together the tray. It's really, in comparison to the other trays I've made, this one's very simple. It's a two compartment. One is the tailings part, and the other up here is where the concentrate goes. And I'll just weigh those joints down with a couple of lead. Yeah. To continue to work on the tray, I've put a couple of 1-inch diameter holes in here. I want 3/4 inch PVC to sit in there. And to get it to get the hole big enough for that to happen, I'm going to use one of these sanding drums on the drill press and just open it up. And I've glued up the tray and it's drying, and I'm just using some clamps to hold it down while it dries. So at the moment there's no fasteners like nails or anything in this. Okay, here's the tray, almost done. I need to put in the little shelf that moves the water that direction. And I'll just glue that piece in. So I'm working on the baseboard. This is the thing that supports the table. And this has an adjustable angle to it so that I can level it. And the way I'm doing that, these are pull down posts. That's a pilot hole for that. And here's the adjustment mechanism. So there's a knob, and this is an Acme thread and a nut. And so those nuts get epoxied into here. I've just used a chisel and made a hex hole for that. And the epoxy will hold that in as long as I put some nicks in the nut so that the epoxy's got something to grab onto. So I'll do that, and I'll epoxy these nuts into those recesses. And there's the nick in the nut. Nicks in the nuts. All right, so I got a bit of JB weld. Butter up your nut. And slide it in there. Now here's the top. And the epoxy has cured for about 24 hours, and it's quite nice. So I don't think I'm going to need another layer of epoxy on here at all. I'll just take some 220 and finish off this surface to make it nice and smooth, getting ready for the paint job. So here's a close-up of how the grooves came out. Really quite nice. I think the epoxy is plenty thick enough to prevent water from damaging the surface, especially with many coats of paint on top of this. Now I'm going to mount the lower flexure supports. These are the uppers, but I'm going to put the flexures onto here so that I can align the lower supports perfectly. So there's what it looks like. I've got it positioned about where I want it. It's a little bit shifted that way. It's not quite centered because I have the because I want this port, the concentrate port, to go down and clear the table underneath here. So that's about where I want it. this is the tailings port. It's going to have to go off in that direction, I think. And here are the two spacer bars that I used when I glued these guys in. So I think I'll just use those again. I think I'll just line it up like that, glue it in, and then I'll take care of screwing these things in from the bottom. So there's the spacers. That keeps everything parallel. It keeps that parallel with that, which is very important to the operation of the flexure. All right, next thing is to glue on the tray. That's exactly what I wanted. I want to drive it at about 5 or 6 hertz. So I'm going to put a motor in there. You know, it's going to move this back and forth a bit faster than that. The next step in the process is to put the back on. This is 4 inches wide and the exact current length of the table. All right, got that clamped up. I let that go for a couple of hours. Now I've cut out the sides. This holds the pipe that connects to the water bar through this hole, and on the other side it's just a plain hole. So the water bar goes through here and is held by that arrangement like that. Well, I put the sides on, and I've got these little support posts in the corner gluing up. That greatly stiffens that corner. Actually, it strengthens it too, which is mostly the purpose. And now I'm using this product, which I like a lot, and I'm going around and I'm filling the gaps. So I need it to fill with epoxy and paint, and the best way to do that is just to take the time and fill this carefully with the putty. And then as the putty sets, it'll reach a point where it can be easily sanded. So I'm going into these corners, and I want to lay in a fairly good fillet in all those corners. Okay, here's the back side of the tabletop. The last small job is to epoxy these nipples in place, and I'll do that with JB Weld. Okay, so I'm going to start making the motor now. This is a piece of mild steel. It's 3 inches wide. I think it's 6 inches long. The magnets go here and here, and this provides a path for the flux, a low reluctance path for the flux to go through. Get that out of the way. Here are the magnets. These are about $20 a piece. These are neodymium magnets. They're 2 by 1 by 3/4, and they are super powerful, and they're quite dangerous. I had a friend who played guitar, still does, and he lost the tips of 3 fingers on one hand, doing something that he shouldn't have been doing. So those magnets have to safely go on here, and one end facing up has got to be north and the other has got to be south, so that the flux goes around like that. And so I've got to put, I'm going to mark on here where they go exactly, and then I've got to put the magnets on there safely, and this is a bit of a trick. All right, I've got the location of the magnets. One magnet goes here, one magnet goes here. And as I said, on one magnet, north has got to be down, the other magnet, south has got to be down. And I don't care which way is actually north and south at all, because that's just a polarity that I can, take care of in the electronics. So I can't get that close to these magnets. So what I do is make sure I don't ever lose track of what I've got. That's got to go down, and that's got to go down. So it comes like this with a safety thing in the middle, and it's strong. It's hard to get, you can't really break that apart very easily. So I'm going to hold this down, get it close to the edge of the table, and then bring it up like that. So I've got a persuasion device. I'll just persuade that guy to move into position. All right, so that's close enough at the moment. Now, I've got to get this off of here. So the way I usually do it, turn it 90 degrees, pop it off. Okay. Now, once again, I use the edge of the table, hold this down, bring this up, and that is the safest way that I know of how to do it. And that's pretty good. Okay, so now there's a huge amount of flux, magnetic flux coming out of this pole and going into this one, and then it returns through the mild steel. And here's the coil form. I'm going to wind 24 gauge wire onto here in a minute. So that coil is like here, and the flux passes through the coil, and then when I put current through the coil, it'll want to go either this way or this way. That's the principle of operation, and it works. All right, let's talk about the coil form for a second. I got a wooden core. I could put mild steel or iron into the core and increase the flux, but I don't want to do that, because if I do that, then that gets attracted to these magnets and it puts a huge amount of vertical force on the table, which I don't want. It also makes it dangerous. So it's much better if this is completely non-magnetic. It's just a loop of wire. Okay, so the core, the wooden core in there is 2 inches in diameter, and there's a couple of holes for the wire to start and end here. And I'm going to wind a coil that's about 3 1/4 inches outside diameter. And let's do that next. I'll go find the wire. All right, so here's how the coil gets wound. Here's a spool of number 24 wire. Here's my coil form. And I've got it set so that it'll wind nice and slowly. I can count the turns. The wire start goes through that hole that I showed you. And I've got to be careful that this doesn't get tangled. So what I'm going to do is to move this way over here, move the camera. That gives me a better angle, and then just start winding. So I've got 1, 2, 3, 4, 5 turns on it so far, and I'll just count as we go. All right, so I've wound about as much. I lost total count of the turns, and it doesn't make any difference. I've wound about as much as I can get on here. There's my exit hole right there, so I'm going to use that. I'm going to twist this together. Well, there's the finished coil. It measures 10 ohms, which is just about what I was shooting for. Now I'm mounting the magnets, part of the motor, using a layer of JB weld. Right, so I'm going to mark out the locations where I want the holes in the water bar. There's a PVC cap on this end. On the other end I have an elbow and a nipple, and this goes to the water supply. This goes down to the pump pumps water along the water bar. And so there's 27 inches between there and there, and so there'll be 28 holes. All right, I got a little paint on the table. This is the part of the motor that has the magnets, and the block is the bumper block. Like this, and finish the job of putting it together. And that'll allow me to figure out the spacing to the motor. And then I'll be able to finish the mount of the coil mount of the linear motor. Well, there's the table. That's the idea. The natural frequency is just about where I wanted it. It's a little bit lower than the frequency I'm going to drive it at, so that's good. Well, here's the finished magnet side of the motor. I think it's finished anyway. This is neoprene rubber. That's the bumper. So the idea is to bump up against that. Now I need to make the other side of this, which is the side that holds the coil, and we'll get on with that. I now know the exact spacing between that surface and the bottom of the base, or the top of the base. So now I can make a little box to hold the coil. All right, so before I put this back together, let's take a look at what we've got. Here I've got the carriage bolts. They're 1/4 inch. They hold the flexures on. Here's the motor. There's the port, the electrical port for the motor. The coil. This is, of course, just 1/2 of the motor. This is for the bolt that goes in here with the knob, I guess you'd call it, that adjusts the bump, the location of the bump. We've got leveling screws in the corner. These are for the hold down bolts. There's studs in the base. And now I'll put, let's take a look at the table. So there's the table. There's the flexures. So here are the magnets, and this is the bumper. And there are screws holding this piece on there. The ports, this is the high grade port and this is the tailings port. This is in completely the wrong location. I need to move it to make the exit, the water pipe part of it work. I need to move this to about there, right at the end of the tray that takes the tailings out. And that little stub is exactly the right size for the tailings, because I want that to be as close as possible to there so that this pipe clears the base, which it now will. And that keeps the plumbing simple and direct. So here's the little stub. I've roughed it up with 80 grit sandpaper so it's got some place for the glue to bite. Here's the assembled unit. There's the resonant frequency, and it's nice and quiet. So here's a look at the assembled motor. I've got roughly 100 thou gap there and there to the magnet coil form. Building the electronics box. That's perfect. All right, so I glued a top on it, screwed it in, and now I'm cutting it off. I've added this rim that holds the aluminum plate that goes here. So here's the electronics that makes things go. 12 volts from the battery comes in here, and it goes into this, which is a boost converter. That boosts it up to 18 volts. The 18 volts drives the two PWM motor controllers and this H-bridge switch, which drives the linear motor on the unit. The 12 volts also comes into this buck converter, and it comes out at 5 volts, and it supplies power to this microprocessor, which is doing the work, telling the motor what to do. This is the main 12 volt power. It's an SAE connector. And there's the three outputs, two for the PWM and one for the linear motor. And then a programming port here for the micro. Here's the finished electronics box. It has knobs and readouts, etc. It works very well. The basic idea is just to make the linear motor go back and forth with adjustable frequency and amplitude.